My Earth Science Minions video 2. We on page. I don't even got it right on this packet. Okay, hold on. We on page 6. We're going to get into erosion. There's probably going to be a Bill Nye video in this thing, but I'm going to skip over it. I'll put that link in separate for you guys. So, right up top, erosion is the movement of weathered material. Okay. Just a movement of weathered material. Here's some pictures of some stuff. You can see that there's weathering happening right there. That was almost a little landslide going on, right? And then here, you can see the shoreline is definitely changing because of the water erosion. All right, so greatest force is gravity. So next to gravity, I want you to write the greatest force. Gravity definitely does, right? Greatest agent is definitely water. Water is a very powerful agent. So gravity is the greatest force. Down a little bit though, you see where it says water on the left-hand side? That's where we can write greatest agent. Okay, and we'll get back to that when we get to water. So first, let's get into erosion. I think that's the Bill Nye. We'll get back to that. Gravity. All right, under mass movement, what mass movement means, what gravity can do, right? Can cause a mass movement of materials that can take form in a landslide. Hits the news every once in a while, right? The speed depends on the slope, the material, and water. If it's like this, pretty flat, not going to go so fast. If it's steeper, that's the slope. Now the material is going to get moving faster. The speed of the movement, the speed of the erosion will go up. It's angular and unsorted sediments that are the things that are going to move here. Angular and unsorted sediments will be moving by gravity. Good. Now there's going to be some learning pieces, I believe. Nope, we're writing the glaciers. We're still writing. So this is already written for you, right? Surface bedrock is scraped away and redeposited. So this again will be part you're writing, angular and unsorted sediments. There you go. Drumlins, erratics, kettle lakes, and striations happen. U-shaped valleys. This goes under the two types of glaciers. Continental, which is a large coverage area, and alpine, small and high in the mountains. Those are the two types of glaciers. Not a ton of room to write that there. You can definitely get alpine and continental, but you might need a little extra space to understand what those words mean. Sorry, it's loud outside, so I hope it's not causing too much background. Okay. This is not really notes you're taking, but just thinking, what's the agent of erosion responsible for carving out these U-shaped valleys? Well, glaciers, we just talked about them. Glaciers carve out U-shaped valleys. Next piece, water. This is, of course, you should have written greatest agent already above running water. I should do that earlier. Running water. So size of the material depends on the stream velocity. What that means is if the stream is running very fast, it can move bigger rocks. If it's moving pretty slow, it can only move tiny little sediments. Okay. This creates a V-shaped valley, not a U-shaped valley. That's the difference there. And the sediments become sorted and rounded. The water friction rounds them, and then the size of them, how far they're going to go down the stream, is based on that water velocity. And the bigger stuff is going to stop before the smaller stuff, and it ends up sorting itself out. Okay. Then underneath waves, move sediments parallel to shore. It's like in the ocean. Depending on wind velocity and wave velocity, again, sorted in round sediments. Okay, we're almost done with this video. Here's the difference. Notice this is more of a V-shaped valley. So this one is due to the water. Right? This is due to running water. Just to give you an example of what's going on. And I really can't wait to listen to this video and hear these guys in the background. I'm really sorry for the extra noise. Wind carries sand-sized particles and smaller. So notice it's not a wind ain't going to take a boulder. Okay. Sorted, rounded, and pitted. Now sediments, that pitted is going to let you know it's from the wind. So there's a keyword. It's italicized. You might want to circle it so that if you get a question that has something about pitted sediments, you know it's been wind eroded. Again, depending on wind velocity, because the higher the velocity of the wind, the more stuff and the bigger the particles that can go. So here's a good picture of desert wind erosion. Here's a good picture of what the pitted erosion looks like from the wind. And then this is, again, just learning for you guys, not taking notes on this, but notice the slip face and where the side of the sand dune is, and the stable and the unstable accumulation buildup. Okay. Then looking at this, you can see that it's going, the wind now is going in that direction. Okay, you see the ripples, and then you see that nice curved out piece there, which is the opposite of what the picture was, but that's what it's going to show you. And hopefully you have enough room to write this. Velocity, speed depends on the material and the gradient and the slope. And of course, having water. Okay. All right, with that, we're going to call it a day. For this notes, next page, we're going to get into soil creep, debris, mud flow, and that kind of stuff. So notes are done for now.